Swadika, good afternoon and very good morning to those who just joined us from Europe and India. I'm Rose Chitanuwat. I'm going to be the moderator for the session today. Once again, this is the webinar by APC, which is about the ASF Expert Series, how to combat this long battle and succeed. If you remember last 2 months, we also have kind of this session by APC, which is bring Dr. Blom and also mention address about the issue of ASF. This is the continuous series. From you seeing on the video of APC, it's very impressive and very interesting on the driving that APC bringing the solution into the market during this period, and even also continue to give the knowledge and content from the experts from various fields, especially in swine, to the market. And ladies and gentlemen, today we have more than 300 people registered for this session. I think that is because the very interesting speaker that APC will bring today. Before I'm going to be in the session of the presenters that we invite here, I would like to invite Mr. Ramesh Subramaniam. He is the Director of Sales of APC in Asia Pacific, to have a bit of introduction about APC. Yes, please, Ramesh.
Thank you, Ms. Rose. At this long battle and succeed. So over the last 1 year, we have been bringing global experts on the subject and share the latest information on ASF globally. We have also been offering some of the nutritional strategies to enhance the immunity and efficiency of production. Today, in the session, we are extremely honored to have Professor José Sánchez-Vizcaíno, who is a director of the OIE-ASF Reference Laboratory in Spain. OIE, which is the World Organization for Animal Health, is an intergovernmental organization coordinating, supporting, and promoting animal disease control globally. As you know, African swine fever has been the biggest challenge for the global swine industry for the last several years. So he would be covering the current situation of ASF globally, how it is spreading in the 5 continents, and what are the different strategies to control the ASF. We also have Dr. Javier Polo, who is the Senior Vice President Research and Development at APC. APC is the global leader in spray dried plasma production. So Dr. Javier's presentation would emphasize on the biosafety and traceability of plasma, and he will give a gist of our 30 years of research on plasma that we have been doing, and how plasma could be an excellent tool to improve the efficiency and gut health. So in a current scenario where the raw material and feed cost is very high, and the peak prices in some of the markets are lower than the cost of production, efficiency makes a very important agenda for us to consider. So just to set the stage, I would like to take the next few minutes to go through what about APC corporate introduction and about a brief introduction about the company as such. So we are part of the LGI group, which is the Lauritsen group. It's a privately held company founded in 1975. We are headquartered in the US in the state of Iowa. Globally, we have 60 production facilities and over 2,500 employees. The focus of the organization has been on value-added protein technology, and also in the extraction and fractionation of proteins from complex biological fluids and its scale-up. So we will have Dr. Javier cover some of the aspects of this during his presentation. The group itself, the LGI group itself, has a long history of over 100 years. The Lauritsen family started with a dairy creamery in the state of Iowa over 100 years back. Now, the company is a diversified business catering into human nutrition, into pharmaceuticals, and animal nutrition. We have 7 companies under the umbrella of the LGI, and APC is the largest company in that group. APC was founded in the year 1981 as an entity. We are currently the world's largest manufacturer of spray dried plasma and functional proteins with global reach in terms of marketing and technical support. Some of the facts that you may be finding it interesting is that in the year 2008, the American Society of Animal Science did a survey about the top 10 discoveries in the swine nutrition in the past 100 years, and plasma has ranked number 6 in that. APC operates in 17 manufacturing factories around the world, catering to, we are based in North America, in Latin America, in Europe. APC is a founding member of the North American Spray Dried Blood and Plasma Producers Association and a working group in the American Feed Industry Association. APC has been granted over 20 patents in Europe and in US for the collection, processing, and feeding of blood and plasma proteins. All this has resulted in more than 600 peer-reviewed journals and articles relating to the mode of action, safety, and efficacy of plasma across different species. The cornerstone of the success of APC has been its focus on innovation, research and innovation. We have 2 R&D centers, one based in Iowa and another one based in Spain, where Dr. Javier is based. We also collaborate with some of the leading universities around the world to do applied research and publish the papers. These are the products that we are going to talk about. We have 2 categories of products. One is the plasma protein. The brand names are AP920, AP820. We also have the UV processed plasma protein, and also these have dedicated porcine, 100% bovine and 100% porcine products. We also have hemoglobin, which you also call as red cell, which is a very highly digestible source of protein for the aquaculture diet as well as for the dairy calves. The biggest application, the largest application for plasma is in the swine diet. So the target is the early stage or the phase 1 stage of the nursery program as part of the transition feeding to enhance immunity and to reduce the stress. In poultry also, we have this early phase of nutrition. We are talking about 7 days or 10 days or 14 days, depending on the feeding regime that somebody will be following, to get a dosage of about 1 to 2% in that diet to give the immunity boost throughout the life cycle. We also cater to the aquaculture sector through our hemoglobin product, which is a highly rich source of highly digestible proteins. We have significant footprint in the pet food sector, both in the wet and in the dry pet food. In addition to the nutritional profile, in the wet pet food, it also acts as like a functional ingredient to enhance the gelling effect or the emulsifying property and improving the production efficiencies and the quality consistency of the product. In case of the dairy sector, we supply to the calf milk replacement market and hemoglobin as a source of highly digestible protein in that sector. In the agronomy or the agriculture sector for the crops, we have this biostimulant which helps in better root growth and in better yield of the crops. In terms of the global presence, we are globally present in terms of manufacturing as well as in terms of sales operations. So if you look at the production centers around the world, we have dedicated porcine and bovine plants with 7 plants spread across in US and in Canada, but also we have about 5 plants in Europe and 4 plants in Argentina and in Brazil. The plants which supply into the Asian market are predominantly from United States, Canada, UK, Spain, and Argentina. This is our Asia Pacific footprint. We operate through distributors and long-term partners. We have completed 25 years of our presence and sales operation in Asia, and we would like to take this opportunity to thank all our partners and customers who have been with us in this journey. This is our team in Asia. If anybody would like to get in touch with, these contacts are available on our website also. We can be contacted and reached through the social media platforms, and we would be happy to support you. Thank you for your attention. Ms. Rose. Yep.
Sorry for that. I have some technical issue. Thank you very much, Mr. Ramesh. That's a very brief detail about APC. If you want to explore more, just scan the QR code and get to know APC team more and more. Have been working with APC as the webinar provider. They are very professional, and the connection is very strong in terms of the experts from any other country that can bring knowledge into our Asia Pacific with the lead of Mr. Ramesh. Thank you very much once again for the industry to have such a great company like APC. So for the next session, we are going to stay together here till 4 p.m., which is altogether 2 hours. We're going to have another 2 speakers, which is Mr. Ramesh already introduced to you guys, and we will end up with the question and answer session at the end. To have a little short housekeeping again, if you have any questions, please put in the Q&A. Then we will bring up to ask the panelists during the Q&A. And also, if you want to reach to any APC team, you can put your message in the chat box below. Right now, Professor José Sánchez-Vizcaíno already ready for sharing with us. Professor Jose, he is the full professor of the animal health at UCM, or University of Complutense of Madrid. And as Mr. Ramesh mentioned, he is the director of the OIE-ASF Reference Laboratory. I would like to give a bit of the profile of Professor Sanchez. His DVM and Ph.D. from Complutense, and then completing his postgraduate studies in immunology and animal virology at Cornell University. So he is full professor at the Complutense or UCM. He has more than 240 scientific publications in high impact international journals and author for 47 chapters in international renowned book. He has been the IP of more than 150 national and international competitive research projects and director of 34 doctoral theses. Wow, that's quite long. I would take about 1 hour to complete his CV. So ladies and gentlemen, let's us welcome Dr. José Sánchez-Vizcaíno together to cover on the unstoppable spread of the ASF virus already in the 5 countries. Please, Dr. José.
Thank you. Thank you very much, Roses, for this presentation. Good afternoon to all our colleagues and friends from Asia, and good morning to the Europeans one that is joining already. I would like at this moment to thank APC for these invitations. It's really a great honor for me to be with all of you and have the opportunity to review with you the situation in ASF. I'm going to put the presentation and start talking with you already. Okay. So you see the presentation too? No problem?
Yes, excellent, sir.
Beautiful, beautiful. So we're going to review today several points that I think could be very interesting for most of you. One of them is to make a review of the global situation of ASF at this moment. Also to review the current risk that we have, because there has been several changes in the last times. What can we do to reduce our risk on African swine fever introductions? How to be protected? What is needed for that? How to do an early detections and a good diagnosis and a good contingency program, how is the ASF Bacdiva vaccine current situations, and of course to answer to any questions or comments from you. So I am working on African swine fever since 1978, and this is the worst situations that I never saw in my life. So at this moment, African swine fever is already in 5 continents, in the 5 continents of our world, and it's already affecting more than 50 countries, presenting 8 epidemiological different scenarios. And so this is the worst situations, as I told you, I never saw before. You have to remember that just only in this area of the world, more of the 78% of the world pig population is living, and all this is in risk. Very recently, we have the infection of Dominican Republic and Haiti in the American continent. And as I told you, this is the worst scenarios since 2007, that was the last exit of African swine fever from Africa. So let's see how is the situation. First of all, I would like to tell you that in general, this disease has been underestimated. One of the reasons is probably that the people don't know too much about this disease. This disease has been normally exclusively in Africa, with several short paths to other countries, has been for a long period of time in the past in Portugal and Spain and some other European countries, but there is not a really well-known disease. And now, since 2007, we are now in 2021, so already 14 years, and as I mentioned to you before, 5 continents are infected. So one of the problems is that some little details or important details of this disease are not very well understood or not clear for most of the people. Let's give you situations starting in Africa. Africa is where the virus was described, first of all, and we have 2 different scenarios here. One in the east and south of Africa, that is this area, where the situation is the most complicated because there is a continued production of virus. You're going to see now this situation here is quite complicated. The West Africa is different, and West Africa is still there, the disease, but will be more easy to eradicate it or to control. What happened in the East and South Africa? What happened is that there are already a very continuing production of virus. The virus was reported in Kenya in 1921, and we have already in this area all the different genotypes that has been described in African swine fever. Let me tell you that genotypes are not serotypes, and I'm going to explain you why we have to do in African swine fever genotypes and not serotypes, like in most of the viral diseases that affecting human or animals. The reason of that is the lack of neutralizing antibodies. So we really don't have this beautiful tool of the immunity, and that's why we have to really try to define the different type of the virus in genotypes. I'm going to explain a little later, a little in more details what that means. In this area of Africa is where we have already the sylvatic and domestic cycle that is coexist all the time. So these 2 animals, the bush pigs and the facochero, these are tolerant to the African swine fever virus. So that means that they never reach the virus higher than 10^2. With 10^2, these animals don't have important lesions and they don't die for this type of infections. But they became carrier of the virus. So that means that they have continuously the virus in their body. And together with this animal are living these vectors. This is Ornithodorus mubata. Is a soft tick, as you can see, and this soft tick is able to bite this animal, take the virus 10^2, and transform in their own body, because they are not only a mechanic vector, they are also amplify the virus. They transform in 10^2 to 10^7, and that is a high doses that go against the infected wildlife or domestic life. So that is the cycle that we have in Africa. And this is the production of the virus. The virus leave in these occasions, this third time that the virus leave Africa from this part of the world. So let me show you now Europe. In Europe, we was infected as well. We have two different scenarios. The East Europe, including 2 or 3 countries of the European Union as well. The biggest problem that we have is in domestic pig, and less problem, but also problem in wild boar. So it's a mix of wild boar and domestic, but with quite a lot domestic infections. You can see the domestic in red. So you can see the red point if you compare with the blue point that are the wildlife in this part of the world. In contrary, we have in the west part of the European Union just the opposite situation. Our biggest problem in this part of Europe is the wild boar, with very few domestic problem. So this is the 2 different epidemiological scenarios that we have in Europe. In Europe, the disease started in 2007, starting in Georgia, coming directly, as you know, from Africa. And many countries start to be infected. As I mentioned to you, in 2014, Lithuania, that belonged to the European Union, here in the border, was infected by the introduction of wild boar into this area. The same happened with Poland, with Estonia, etc. So the situation now in the European Union, I mentioned, is our biggest problem, is the wild boar, and we have already some success in the control of the disease. It's very important to remember the Czech Republic, the Czech Republic that is already free of ASF, and it has been declared by the OIE as free of the disease. This country was infected mainly also in wild boar. The same happened with Belgium. The Belgium also is already a free country, but also has been infected in wild boar. And probably very soon we're going to have also the island of Sardinia recover and totally free, because the program that they started in 2015 is really giving very wonderful results. They found what was the big problem of the virus, what was the reservoir of the virus, that was the free-ranging pigs, and they are already more than 2.5 years with no outbreak in domestic or in wildlife. So that is at this moment the situation in the European Union. I'm going to give you more details. I'm going to give you the details between 2014 to June 2021. So in 7 years, I'm going to show you that at present, 37% of the European Union countries, 10 of 27 are affected of African swine fever in domestic. We have already 5,353 domestic farms affected with ASF, and 38,875 wild boar notifications with African swine fever. You can here see the difference. The wild boar here is green, the pigs is in color and rose or color or pink color. So you can see that distribution. As you can see, the biggest problem is already in this area where we're connecting European Union with the rest of the European countries from outside of the European Union. So the 87.9% of our problem in the European Union is wild boar, and at 12.1% is the domestic problem. But the wild boar we found in the European Union that are not only in the natural areas, we also observed this animal can be infected, and this is the percentage of infections that we found wild boar in different areas, in the natural areas, in the agroforestry areas, or agro-urban areas. So you can see the wild boar is spread not only on their habitat, in their classical habitat of the wild boar, but also in the agroforestry or in the agro-urban. So we have already a 64% of cases of wild boar affected in the natural areas, a 20% the cases that has been described in the agroforestry areas, and a 12.4% in the agro-urban areas. So that is a big problem, and this is really our main problem, as I mentioned to you. So this is how also there is an interaction that is also important to remark, and is that in the natural areas, we also found an 11% of infection in domestic pigs. So that means that some countries of the European Union have already farms in the natural area of the backyard. Of course, this is a problem, and we know that this is something that we have to remove soon as possible, because to have it in the areas of the wild boar where it's already highly infected is already a big problem. In the agroforestry, of course, the cases that we have in wild boar are less, and we have more in domestic, and in the urban, we still have problems with wild boar, 2% of cases, but 10% in domestic. So that gives you an idea that we have to this interface that is very important, and this is why we have so much trouble already. The interface between wild boar and domestic at this moment is really an important point, and this is what we are already fighting a lot to control. The next situations that I would like to review with you is Asia, and in particular China, because in China several changes happened in very recently, since 2020 and 2021. And as you know, China has been infected in 2018, and later several countries was involved. I'm going to show you how is the situation at present. But I want to pay attention, to put the attention at this moment in these two publications from our Chinese colleagues, one in the 2020, the other in 2021. What they found that there has been changes on the situation of the disease, and they found different African swine fever attenuated ASF virus. Until now, in China, the disease that has been running in African swine fever was acute African swine fever, but they found this attenuated one, and later they discovered that it's not just in a few places, but also in other. I'm going to give you a little more information. At this moment, 16 of the 28 countries and the regions are affected with ASF. Also, Oceania is also affected, as you know. Very free countries, very little free countries still are there. And as I mentioned to you, in 2020, our colleagues from China found in this area that is affecting 7 provinces. In this area, they found attenuated ASF virus isolations. That was founded in the second part of the 22. And so from the 22 samples that they evaluated, 11% had mutations or deletion of the gene CD2V. This gene, the CD2, is related with attenuations. So it's one of the genes that we know better related with attenuations. So at the beginning, they thought, our colleagues thought that probably was an evolution of the virus after being infected for several years in China and in many, many animals that probably change it and they make mutations for attenuations. But a little later, they found that in 3 of these provinces, and these 3 provinces, they found not only attenuated, but they also found strains of virus isolations that has been 7 genes deleted. 7 genes, deletion of 7 genes is just more difficult to thinking that these are mutations, because that means a lot of mutation, a lot of genes, and not only mutations, deletions. So this look more like vaccine or legal or illegal vaccine that has been treated by deletion of the genes that are related with virulence, and that what they found in these 3 provinces, that there are several virus isolates that show very low virulence. They lose the capacity of the virus from hemoabsorbing, but still have high transmissibility. The incubation period is keeping longer. Now is around 30 days. It's partially dead, so some animals survive, but some other doesn't. And the ones that survive, they present subacute or chronic lesions. So that means that we are already to 2 different scenarios in China. One's the biggest one that is related with the classical infections that they get, and it's a virulence virus of ASF, but they also have already circulating, at least in these areas, perhaps already in a longer area, these attenuated isolates that look that are vaccines, vaccines that has been produced by human. So the other things that surprise us very much from Asia in general is that the population of China, in particular in Asia in general, of wild boar is very, very high. It's very, very high. And Europe is quite less. So this color gives you the population density. So the yellow, white is very low, and the red and brown is very high. So in Europe, that we have a less populations, the high population of wild boar is quite a lot of less than in China. We have a lot of trouble with wild boar, as I show you. But here still has been not noted the important effect of the wild boar. So they mainly have domestic one, and I don't know if they are not really already interested in the wild boar because they don't found anything, or they really don't look at to that. Because as I show you in Europe, the wild boar is absolutely terrible to spread the virus from one side to another. So probably they also have more affection of wild boar. They only declare very few outbreaks in wild boar, but in Europe, as you saw, it is terrible, the situation there. So we are interested to know what really could happen in the future with this situation. So this is the PREDICT ASF programs that we have for the introduction in wild boar, and you see that it's very high distributed in this area of Asia. So the situation in China now can be summarized by different risk factors that I would like to review with you because are important for the rest of the countries as well as for our colleagues from China. They have, by tradition, two habits, and it's the use of blood plus feed the animals. So they buy blood in the slaughterhouse, and they put the cereals with this blood and give it to the animals. So that is really a very high risk at this moment because there could be a lot of animal infected, and you see only 200 microliter, that is a drop of blood, already have 3 million copies of virus. So they are using a very high risk to feed animals by this system. But also, especially in the family and in the backyard production, they still use the swill feeding a lot from restaurants, for houses. So in the swill feeding also could have a lot of virus in the meat and in the product, in fresh product that are not treated by heat. So they also give it to the animal. So they could have a recirculation of virus in this area of the production of China. That means the backyard and the family production. There is also a high possibility that infected animal or carry animal enter in the slaughterhouse, so increasing this potential infection, as well as we found several vehicles with difficulties in disinfection, so with a high level of infection in vehicles. Also, unidentified pig transportations, the biosecurity and the families and in the backyard is very low. In contrary, they have a fantastic industrial production that is quite higher and very good biosecurity, but with the family and the backyard is very low. There is no compensation to the farmers, and this is a very important topic that I want to point out, because if you don't compensate the farmer that can be infected, the farmer is going to use the meat, or they're going to do whatever to not lose so much money. So it's very important to don't forget that using not compensation to the farmer is not good, because the farmers that became infected, especially the small one, they're going to try to sell whatever is possible unless they lose everything. Also, according with the publication of our colleagues from China, attenuated strains are already circulating, probably related with vaccine or the reaction of vaccine with the virus that was circulating before, but this is what they described it already. And it's a high population of wild boar, even that they still don't look like it's creating trouble in China. But this is something to keep in mind. So this is the problem I see already. So there is could be a lot of circulation of virus, and they recirculated because they use soil feeding again. So they go to the farmer again, the virus in. So this situation produce a lot of products that are contaminated and can live not only inside of the country, but perhaps and outside by many different ways outside of China. So how can we be protected under these situations? The first things that I think is important for all of us this morning is to review how is our enemy, how is this African swine fever virus, just to make more familiar, especially with the transmission mechanism, how the virus is moving from one place to another, which are the mechanisms of infections that the virus use more frequently. And this is very important to review with all of you. Also, be aware of our own risk. So I think that all of us have to think in our own farmers and our own production. And after we describe it, the important point of the transmission, thinking, okay, what kind of risks are already in my farm? How I can stop this risk? We're going to review that. We're going to review our biosecurity and also to see how we can make a very early detections, because this is another problem in African swine fever that we are observing, is that we are observed very much that the detection of a potential disease, the detection of a potential outbreak is very delayed. There is not very early. So that is bad, because by the time that the samples came to the laboratory and the diagnosis is established, it's already late and the virus is spread to many other farms. We're also going to identify these clinical signs and these lesions that we have to pay attention when we saw on the field. When we saw in our farms, this lesion could be African swine fever, and it's not the pathognomonic. The lesion in African swine fever are not pathognomonic, but are very, 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 very clear that could be African swine fever. I mean, they are very, it's very important to say, okay, why not thinking in African swine fever? Because are very, 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 very similar to the problem in ASF. And that is important. We're going to review these clinical signs and these lesions. At the same time, I think it's also important to have a fast and effective laboratory diagnosis. So I'm going to talk very quickly which technique have to be well used and can be presented and used for most of you. And finally, we're going to see how make a specific surveillance and contingency program for each country, because you know the situation, the epidemiological situation in the different countries are different, and so they need a specific contingency program, not a copy-paste program, because that doesn't work. So the main route of infection outside of an infected country and also inside of an infected country has been produced by product that is used for human food, but are infected with ASF. As you know, ASF doesn't infect humans, but could be in the product, and the virus is very resistant and can be for a long time. So these contaminated products can leave the country, the infected country, and go outside and go to many different other. It's not a big problem in the important airlines, because airlines have a very strong control in that situation, as well as the big boat for humans, for people that go in tourists, but for a small airport, for boats that are with all these products that they have this container, and it's full of container, and they are traveling for many countries, and all this situation is very important to thinking about. And this is the way how the virus enter through other countries, we're going to show you how the mechanism is producing. Also, we have to remember that the virus in blood is very, very high doses, and it also is very resistant. So in one track or in one boats or in any other things like feces that could be blood, you can be sure that the virus is going to be there, and that means it's going to be in big amount. So we have to be very carefully not carry the virus in our boats and our clothes. Don't clean and disinfect well our vehicles are very important, because as I'm going to show you in a few minutes, the virus is terribly resistant. Of course, we also have transmissions between animals, infected animals to healthy animal, domestic to domestic, domestic to wild boar, and wild boar to wild boar, and also wild boar to domestic. So this is the other way of infection. This way of infection is happen when the virus is already in one country. This is where they spread more. But the entrance at a new country normally is by food, as I'm going to explain you. And the only good news I can tell you about this slide is that African swine fever is not very efficient by aerosol transmission. And of course, it's less efficient than foot and mouth or PRRS or classical swine fever. But they go everywhere because they resisted very much. The virus is very resistant, and very few doses is enough to infect it. What is one of the mechanisms that have more virus, and the mechanism that we have to be more carefully? This is the blood. Blood is very important because, as I told you, is very high doses and one just single drop of blood. Also, this blood can be any kind of hemorrhagic or any kind of lesions, or when you sacrifice an animal or when you are hunting, the blood is leaving and the virus is going to be in high concentration. But also when you produce products, fresh products with meat that is contaminated, also when you perform a necrosis in your farm, you have to be very carefully when you make a necrosis in your farm to be sure that you are in a place that can be terribly safe. Later the blood cannot go out by your clothes or by your boots, and that is important to keep in mind. Hunting is also important. And also don't remember that the flies can transport the blood. As you know, flies love blood and love feces, so they always are put the legs in the blood and later they fly, and this can carry the virus for a few hours, for almost 2 days, where the virus keep infected in the legs of these flies. So in summer, it's very frequently that if you have an outbreak in one farm, this farm can be taken by flies with the blood from the animal, from the dead animal or the infected animals, and they are going to fly to other. This is an important issue. But as I mentioned also to you already, the virus is terribly resistant. It's resistant at 4 degrees in blood for more than 18 months. It's resistant at 4 degrees for 110, minus 20, 1,000 days. So you see in a froze, in a product, they are really very resistant. And one farm that is not very disinfected, the virus can be alive for 1 month. So we are talking about a very highly resistant virus. Also in nature, they keep for long period of time in carcass, also in the floor, in the areas near the water where animals came to drink and they left the feces here. This is very important, and they resist for long period of time, for very long period of time. So if you are living in an area where wild boar are closed or backyard production, you have to be carefully with your biosecurity, and you have to think it and your own biosecurity. So we're going to remember now several points that are important to increase your biosecurity and your own farm. We're going to see that when you have this situation, you have to put double fence, because it's the only way to avoid the entrance of this wild boar. And this is very important. But also it's very important to be far away from backyard productions, because this backyard production usually use the soil feeding to eat. So how this will feeding can enter in one country? As I told you, by several ways. Harbor are important. Harbor from container boats, not from transatlantic. Also in the airport, there's the private planes that they have their own food and there is not control and exhaustive control of food for many ways by tourism that they can take it. So this will feeding that can infected could finish in the garbage of one house, in the several houses, or in a picnic area and several areas of your country. So what's happening is that the wild boar are going to eat that because they are expertise in open any kind of container to take the food. So if the infected is in wild boar, they're going to amplify the virus in the wild boar, and later they can be in contact with domestic. But in the same time, if you have backyard, they're going to use the swill feeding, and they don't know that it's infected because, humans cannot understand that a product that they eat and nothing happened with human can be affected to other animals or any other live animals. So that's why the swill feeding is sending in regular garbage, and they go directly to the swill feeding, and the swill feeding is increasing and multiply the virus, and later by the connections between some backyard and industrial farm, the virus arrive also to the industrial farm. So this is the mechanism, the higher mechanism, more frequently see it in countries that are free of ASF. In countries that are infected for ASF, this is also a very important mechanism of transmission, especially in the backyard production or in the family production. We also have to be very careful with the vehicles. Vehicles have to be not only clean, have to be disinfected, including the owner car, because sometimes the owner thinking that their own car cannot be infected, but he was visiting several farms once in a while. So this is very important to keep in mind. Now, we're going now to see a little about the lesions and how to try to make early detection in your farm as soon as possible to stop the infections to other countries, to other farms, etc. So the typical clinical signs of acute African or subacute or acute is fever, anorexia, skin hemorrhagic, breathing problem, digestive problem, and incoordinations. So you can have a skin with this kind of lesions. We also can have epistaxis, respiratory problem, diarrhea, sometimes with blood. This is what you can have in acute. Hyperemic, the eyes can be epiremic, and of course with fever. And the skin have this, we're going to see several ones. So you will see fever, and we're going to see some lesions that are not pathognomonic, but are very symptomatic, very symptomatic. One of them is the spleen. The spleen is have an splenomegalia, and kidney we can see petechias. This is less frequently than the splenomegalia. A very common lesion is lymph nodes. A lot of lymph nodes affected, sometimes congested, sometimes hemorrhagic, sometimes even with a cloud of blood. We're going to see quite a few. In the skin, animal, especially before die, when they are very sick, this is due to the fever mainly. You can see that this is typical from high fever. And when you have a septicemic, you're going to see this kind of skin very typical in ASF. And this is very important to keep in mind. If these are female and they are pregnant, you're going to have also abortions. You're going to be pericardium, hyperpericardium, and hydrocardium. So that means that the liquid and the blood the liquid in the blood in the area that is protected the heart, you're going to see this liquid. So they created trouble to the heart of the animals. This is also very symptomatic. You can see that. Are significant lesions, are not pathognomonic, but are very significant lesions. Also hemorrhagic in the intestines. And this is very important. The lymph nodes, you see, can be sometimes like blood, totally cloud of blood, because they are really completely hemorrhagic, and is really very dark. And of course, should we make a differential diagnosis specifically with erysipelas as well as with classical swine fever. The lung is also affected because also have hydrothorax. So you see the liquid is in the hydrothorax. The reasons why is so much liquid in ASF and so much blood is because the virus is not only affected the macrophages or the leukocytes or the macrophages in the lung, but also is affecting the endothelial cells. So when they broke the endothelial cells, they produce this type of hemorrhagic, and that's why the blood is very frequently to see it in African swine fever. One again, the splenomegalia. Lymph nodes are very significant, and it's not going to see only one, you're going to see several, very hemorrhagic, very. As I mentioned to you, hydrothorax could be with more blood or liquid, not so red, but hydrothorax is very frequently. The hepatomegaly also can be presented, not as frequently that splenomegalia. Hydropericardia, as I mentioned to you, and hemorrhagic in the intestine. And also if you open that, you will see a lot of petechias and some inflammations all as well by the immune response. In the kidney, you will see petechias, sometimes very clear, some other not so clear. Is not as frequently as the other lesions that I mentioned before. Splenomegalia, very frequently. Intestine hemorrhagic also very frequently. And in the chronic form, this is totally different. The chronic form, the only things that you're going to see is skin lesions and the inflammations, or you see here inflammations, very frequently inflammations here, sometimes with one of these lesions also in the inflammatory area. The animals are relatively no fever or very low, and they are running quite well, but I mean, they have these lesions. So in the case of attenuated ASF, it's more difficult to describe it or to have a suspicion of the disease. Samples that have to be sent is blood and serum. This is fantastic for ASF diagnosis, as well as the lymph nodes or the spleen and the kidney and lung are also very good because the virus, as you saw it, is already present there. We also can use oral fluid for the diagnosis of ASF for virus and also for antibodies and the feces as well. And the transportation of these samples have to be very carefully because it's infected. So we have to be carefully when we send that to the laboratory. We described it very recently, one product that can be very good for you, especially because these samples are inactivated to the virus, so they keep the DNA. So it's good for diagnosis by PCR, but it's not danger to be sent to any places. So this is an sponge that we discovered with some alcohol mixtures. So when you put wet this sponge and you pass through the surface of any places of your farm or also on the face of the animals, if the virus, if this animal or this area is infected, they're going to keep it. They're going to keep it on the DNA. But once that is with the liquid, the virus is inactivated. So it's very good, not for virus isolations, but very good for PCR in the sample. So this is very safe system, and also it's very useful when you want to be sure that you don't have the virus in one surface of your farm or your car or any places where you want to be sure that the virus has not there. For example, in one vehicles, for transportation, etc. So this is how to use it. Just put the liquid in the sponge. Once that the liquid is in the sponge, you just use the sponge. Later you put the sponge again in the liquid, or put the liquid of the sponge in the tubes. You can put the liquid or the sponge together, all together, and send it to the laboratory. And in this moment, the virus is totally inactivated and can be performed the PCR from the very beginning and not in BSL-free facilities. So the diagnosis of ASF, as you know, the most important is detecting the antigen. So that means that the virus is very early and you can find the virus easily in the tissue that already we mentioned. So PCR is the technique that is, the most quick at this moment and safe. But we also can do antibodies, because sometimes you want to know not only that your animal is infected, you want to know also for how long this infection is happening in your farm. So with the PCR, they give you the CT, and the CT is going to tell you how much level of virus is going to be in this sample. But also you can do antibodies, and you can see if the antibodies are already present. So that means that the infection is only between 7 to 12 days, or if they only have antibodies and no PCR already, that means that is a very chronic infection. So they give you a lot of information to establish a good system of control. So you have the two possibilities: antigen detection by PCR and antibodies, and these are the best way to establish the diagnosis. There are several types of PCR. Both of them are very good. The ones that we use more, that is UPL and the King ones. And what happened in ASF infection is what I summarize for you here. In ASF infection, the virus came very quickly and very strong, and the viremia keep for long period of time. After this long period of time, the viremia is going down, and in some animals even disappear. The animal that survive to the acute form, they can survive and the viremia disappear, but they have, some of these animals keep infected and they have short viremia, intermittent viremia. Others are totally negative, but some of them, probably around a 2%, between a 2 to 2.5% could produce viremia, intermittent viremia. These are very dangerous because you don't notice, but they are releasing virus. But you have a very fantastic situation is, in this case, where the PCR is going down, the antibodies are very high, and they keep for all life of the animal for very long period of time. So you can have two patterns when you have ASF. You can have a pattern with PCR positive and antibodies negative. That means that the infection is relatively early. You are here in this area, less than 12 days, between 0 to 7 or 10, and that means that the detection has been made very quickly. But once that you have both things, antibodies and PCR, so that means that you are already in this area, in this area that is very high area, and that means that your detection is very low. So probably the infections that you are already described is infecting many other farms as well that has been related with your own farm. And you have the last phases is when your PCR is sometimes negative, sometimes positive. We are talking about this animal, this carrier animal, but antibodies are always present. So that gives you to you a very good information. Only to do these two tests, they give you a whole information of the epidemiology and the epidemiological scenarios of your case. So the problems that we found very frequently is the late detections. So in the farm, in the veterinarians, they don't distinguish very well ASF. The surveillance program sometimes is not good. So these are the causes of the biggest problem for the not early detection, for the late detection. Wrong surveillance program, late detection in field. So that means the veterinarian or the farmer don't distinguish the clinical signs and they don't think an ASF. They make a not complete diagnosis. Probably they only do one part. They do a PCR, could be negative because it's an outbreak, but they don't look for antibodies. So an incomplete diagnosis. Low biosecurity and backyard soil feeding problem. And one important thing is no compensation to farms, because when it's no compensations, the farmer that is infected try to sell their product and don't lose the whole money. So that's why we need a specific contingency program, a specific contingency program that can make it a very specific program for a particular regions or country. It's very important the collaboration between the administration and the private. administration and private have to work together is very important, and also the compensation that I promise you that in countries where there is no compensation, is totally impossible to have an early detection. Totally impossible because many farmers that know that they have the disease, they don't want to declare, and they don't want to lose the money, and they're going to try to sell as much as they can. So there is not a single recipe for ASF, because there are several, as you know, several different situations, different type of production, different type of customer, of habitat, different type of model of productions, animal, backyard, family yard, industrial one. So it's difficult to have a master chief recipe, but what we can tell you is the factors that are very important, the main ingredients to know and to control the disease. And this is based on the biosecurity and biosecurity of your own farm. You know already how the virus can enter by wild boar, by infected car, by infected animal, or by soil feeding. We have to stop that for sure and be sure that we stop it. We also have to be as early detection as possible, because the early detection is going to tell you who infected you and which other you can infect it. If you have just a book where you put the enter that happened in your farm and all the exit of your farm, you can, by the diagnosis, you can distinguish what time is the infection in your farm, so you can more or less have an idea who can bring you the virus, but the most important, where you probably send the virus as well. So this is why it's very important to have this early detection and to have a fast response to stop the spread of the disease in one country or in one area or in one group of farms that belong to the same company. A good and a specific contingency plan is important to have it, but I told you a specific, because I see many contingency plan in some places that are copy paste, and they are really not adapted to the real situation. And what is very important is to have a continuing education and training, and our field veterinarian and our farmer to distinguish the disease, to know the mechanism of transmission, and to be aware to avoid the infection. I'm going to tell you now the last part of this talk, because I think it's interesting for all of you, is how is the situation of the vaccine of African swine fever. As you know, several prototypes are already very promising from different groups. Some of them are already evaluated in Asia. There is one from China, from the Chinese colleagues that are already evaluating from in China, as well as our colleagues from the States are evaluating one in Vietnam at this moment. So the situation of vaccine is already promising. I'm going to tell you how is this situation and what is our own research in that type of topics. Just before I start about vaccine, a few sentences related. African swine fever ASF legal vaccine are closed, but they still are not in the market. But I have to tell you that we have been working for many years to try for a vaccine with a lot of problems and a lot of mistakes. I never saw the vaccine as close as now, and I think that we are very close to have one, but we also have to keep in mind that it still is not in the market, and perhaps it's going to take for 1 or 2 years more. Several prototypes from different research people from Europe. We're going to tell you the research that we are doing here in Europe, from China and from the States are already, and some of them are very promising, but still not ready. We need a lot of animals trials. Why we need animal trials? Because, as I told you, African swine fever don't have neutralizing antibodies, and so that means that they don't block the virus to enter in the cell. So they don't block the infection. So these neutralizing antibodies are very important to establish serotypes and to establish cross protection. And all the viruses, this is the system how we use it. But in African swine fever, we don't have that tool. We don't have that tool because the virus look like don't induce this type of antibodies. So we have to do all the assays in vivo. All the assays have to be done in vivo, assays for security, assays for efficacy, and for cross protection. So that means that they take a lot of time because we have to take a lot of animal, make the studies, see how is the safety for long-term, small-term, and pregnancy situation, etc., etc. Everything has to be done, and especially the cross protection. That means our vaccine protect all the virus isolated that are circulating in the world or only in one particular regions. This is a very important thing. But once again, the vaccine is more closer than ever at this moment. So let me tell you the history of this vaccine very quickly, because I know we're probably a little out of time already. We start to be a little out of time, and I want to have your feedback with your question and problem. We know already that the inactivated vaccine doesn't work. Even the most beautiful inactivated and purified with the vet adjuvants doesn't work. African swine fever vaccine need replication, so inactivated doesn't work. Don't induce immune response and no protection. So unit vaccine that are based on pieces of DNA or pieces of the DNA of some protein or pieces of the protein purified with all the proteins that we already tested doesn't work. So we have a very weak immune response and not protection at all. The only vaccines that still are our hope and the only ones that could be the solutions are attenuated vaccine. Attenuated vaccine induce already protection between 92 to 100% in both in domestic and in wild boar. We also work in wild boar. We are producing not only a vaccine for domestic, but for wild boar, because as I show you, the biggest problem in the European Union is wild boar. The problem with the attenuated strains, with the attenuated vaccine, are that we have to balance very well safety as a most important topic with efficacy. So safety and attenuated are more complicated to establish than dead or inactivated, but in ASF, the only ones that working is attenuated. So we have to do an attenuated vaccine that have to be balanced between safety and efficacy. And in this way, we prefer to have 100% safety, even that our efficacy could be 90 or 87%. We think is more important. So this is the key of the vaccine in African swine fever. I'm going to tell you our project to tell you how we are working and also how far we are already. So this project is a European Union project. The European Union, a few years ago, they opened a call to everybody that want to present a project for a vaccine. So several groups, several consortiums, we presented several different projects, and the one that has been approved by the European Union was our project name is VacDiva, that means a vaccine diva for domestic and wild boar. So we have already several publications. I'm going to tell you who are in our consortiums. We have the laboratories with quite a lot of experience in African swine fever from Europe, and they work with us, and we are together. We also have two important companies working with us. We have MSD, that is the ones that is going to produce our vaccine, and another important company for diagnosis, that is Ingenasa. It's a Spanish European also company for diagnosis kits. And we also have several countries of Europe and our consortium, as you can see here, but also from outside of Europe. From outside of Europe, we're working with the Russian colleague from the center of Ariad in Russia. We also have collaborations with the Chinese that are working with us, and also with the Kenyan people here in Kenya, where we're going to have a pilot vaccination program with the Bush pigs and the Facochero, because this is one of the dreams that I have, is until we don't stop the situation in Africa, we're going to have ASF, and the risk is going to be there. So we are working on that already. So the objective of our project is to provide a safe, look at how I put safe, first, and effective vaccine for wild boar and domestic pig, ready for be registered, for registration, ready for registration. We also going to develop a DIVA test for our vaccine, as well as a program of vaccination strategy to use the vaccine in the best way. Because as you know, the vaccine is a good product, but if the vaccination program is not good, the vaccine cannot be good either. So we want to give it the three things together. We have already 3 prototypes that are working well. It's already adapted to tissue culture, to produce in tissue culture, not only in macrophages. And we have in the side, I mean, in the point of attenuated, natural attenuated one, artificial attenuations, but also the lesions. So we're working with both things. We work with attenuated, natural attenuated, that has been in contact with a lot of different viruses until they arrive to the attenuations, but also we also are producing with this one the lesions. So we have a combination of these 2 groups of vaccine. Several experiments already has been done, and we have preparing already field trial, and pilot vaccination program is already under preparation. So this is where we work in the wild boar. The wild boar we work here in our university. In domestic one is working in another laboratory of Spain and another of Italy, and other 4 group also outside. So that is how we are working. And we are producing in wild boar a vaccine that is oral. So we vaccinated with bait, and the vaccine of domestic is produced by intramuscular or intradermic infection. In domestic, we are between 95 to 100% protection. With some of the candidates that we have already 100% protection in domestic, and wild boar, we have 92.86 protection already with the bait. So this is how is our level of protection. So the animal eat the bait very well. They like it very much because we found one that they like it more. And we are also ready to use this vaccine in pilot vaccination program. One is going to be in Lithuania and the other in Kenya. And Lithuania is in wild boar, and Kenya in the wildlife. And we are also preparing other 2 more vaccination in domestic. Also, we are already evaluating this pilot vaccination. So in the Iruri in Kenya, we're going to see if we can vaccinate this animal from the virus that are already of Africa. So that's going to be very good for us. We're going to see also if the cross protection is good on the different virus that are already there, and also to stop this continuous cycle that I mentioned to you at the beginning. And also in Lithuania, we selected already 5 areas. These are under evaluation and study, and we have to wait until it's approved by the European Union to do this study. And this is a summary of how are our situation in vaccine. Genetic stability in vitro, in vivo, partially is done. We have in vitro studies already done, but in vivo is ongoing. The adaptation of the vaccine prototype and tissue culture, we have already 2 prototypes adapted to the cell line. Other are still not. We have also already described the doses that is good for domestic, the doses and the route of immunization of the domestic and the wild boar. We have already done this work. We have already the immunization with bait done. We also have already done what happened if one wild boar take more doses that is needed for vaccine. Is already done, and I can tell you that don't happen nothing. I mean, the animal not suffer any problem because they eat more bait than what they need for vaccination. We are doing already the duration of immunity. That is going to be a long time and a long experiment. Also, immunization in domestic with larger number of animals is ongoing. The DIVA adaptation is partially done for, as I told you, for one prototype, but we are still doing for the other. Bait conservation in different scenarios is already due on the Mediterranean area, but not in the North Europe, is ongoing already. And the crop protection is already done in domestic and in wild boar with some of these circulating virus, especially with the European one, but still we have to do some from outside of Europe. So this is how the situation is already. And before you go to a coffee break, I'm going to finish or to have a relax from me. And this is our dream. This is the dream we have in our mind, and is to move this color that is already, as you can see, terribly red with ASF, and move it to a world free of ASF. And we hope this dream can be a realistic dream soon. I want to thank you very much for this invitation to APC again, and for all of you to join us today. And also I would like to give my thanks to the University Complutense, to the OIE, to BACDIVA, to the EU for the money for our research, and to my team. This is my African swine fever team, and that is, you see, is young people, very enthusiastic to find the control and the vaccine. Thank you very much again, and I am ready for any comments or questions that you would like to give it to me. Thank you again. Thank you from my
Thank
heart.
you, Professor. So right now, there is a question a lot on the safety of spray dried plasma. So today, Dr. Javier Polo, our Senior Vice President of Laboratory Research and Development Laboratory of APC, is going to share with us on the plasma biosafety and efficient pig production, so from his research. So ladies and gentlemen, welcome Dr. Javier to share with us the study on that.
Thank you, Ms. Ross, for your presentation. And honestly, good afternoon for all the Southeast Asian participants, and good morning for the European participants. It's a pleasure for me to be to share this webinar with Professor Sánchez-Vizcaíno. He is one of the most recognized experts in African swine fever, as he demonstrated during his presentation, that honestly has been very complete presentation about the situation of African swine fever. And also it's a pleasure for me to have the opportunity to talk about the biosafety steps involved in the manufacturing process of spray dried plasma, and how these ingredients can help pig producers to be more efficient. Let me share my presentation. Hopefully you can see my presentation.
Oh, not yet.
Now?
Not
yet? Okay.
yet.
Now?
It's coming? Yes, yes.
Okay. Perfect. Okay. Okay, the agenda for today, I'm going to talk about the multiple biosafety steps involved in the manufacturing process of spray dried plasma. I'm going to talk also about the very recent risk assessment conducted by the European Food Safety Agency, and also about the use of spray dried plasma as a tool to improve the pig efficiency. You should know that the spray dried plasma is a functional protein that is able to modulate the immune system. The common use of spray dried plasma in winning diets, the performance of animals under challenge condition when spray dried plasma is present in the diets, and if there is any difference between bovine or porcine origin for spray dried plasma. Why are we interested in biosafety? As you know, feed ingredients can be a vehicle of transmission of disease. This has been demonstrated, and ensuring the biosafety of feed ingredients is important in preventing disease transmission. In APC, as an ingredient producer, the safety the safety of our product is the highest priority. Okay. But how should we evaluate the risk of the risk profile of feed ingredients? For example, there are ingredients that are not perceived as risky ingredients, but if there is no mitigation process involved, the not risky ingredients can be contaminated and can be a vehicle of transmission of disease. And just the contrary, there are ingredients that are perceived as a risky ingredient from the origin that if you have the adequate mitigation process in place, you can make these ingredients absolutely safe. Then let me introduce you the manufacturing process involved in the spray dried plasma production. In APC, we are we are working with the concept of multiple harvest mitigation technology. This is not a concept that was developed by APC, but we are following this this concept. Basically, this concept also is the recommendation from the World Health Organization for human plasma transfusion. Okay, and basically, this concept refers to the fact that in many cases, multiple low-level mitigation when you are using sequentially are more effective in reducing and eliminating the risk from pathogens than the sum of the individual harvest. In APC, we have multiple harvest steps. The raw blood, we are collecting blood only from animals fit for slaughter for human consumption. This means we are collecting blood from healthy animals, the same animals that we are eating. This preclude to collect blood from sick animals. In addition of this, we have the ultraviolet light irradiation. You will see later on that this is a very strong safety step in the manufacturing process. We have the common spray drying process at 80 degrees without the substance. You will see later on what is the benefit of this step. And in addition of this, we have the post-drying storage. All the products that we are sending, that we are using, we commercialize. For the pig industry, we store the product for 14 days for 20 days at 20 degrees, and this step has been demonstrated that is very effective for envelope virus. Mainly has been effective for PIRS, for PDB, but also recently the group of Sandra Bloom, she's the director of the reference lab for African swine fever in Germany. They demonstrate that this storage at 14 days at 20 degrees was able to inactivate 5 logs of African swine fever. The UV light, the ultraviolet light irradiation is a technology that targets the genome of the pathogens, and doesn't matter if the pathogen is a bacteria or a virus, and also if it's an envelope or not envelope virus. The UV light is targeting the DNA and RNA of the pathogens. In APC, this is a picture of one of the installation of UV that we have in one of our manufacturing plants in the United States. We are implementing this technology in our manufacturing plants, and we have been working with the UV producer, well, with a company that they have designed a system that is able to work with very cloudy liquid, like liquid plasma, but working with a turbulent flow. There is possible to assure that all the different particles of plasma has been irradiated by the UV light. This is a picture of the bottom of a commercial spray dryer. And the spray dryer is a big system in our manufacturing plants, and we are working at minimum 80 degree outlet air temperature, and this is the temperature that the plasma particle achieve during the drying process, and has been demonstrated that the treatment of 80 degrees without this substance is able to inactivate different pathogens. In fact, this treatment of 80 degrees without this substance is a recommended treatment in Europe for meat and milk for human consumption, and has been demonstrated that this treatment is able to inactivate pathogen of concern not only from swine, also pathogens for beef or from poultry. And as I mentioned, this is the post-drying storage control temperature. The package material we always keep at 20 degrees for 14 days. has been demonstrated, and this is a very is a good safety step for different virus, especially envelope virus, as I mentioned before. But also, these 14 days give time to the authorities if there is any risk. This is a table of the effect, the log reduction of the different steps that I mentioned. As you can see here, all this data has been published in peer-reviewed journals. We have that data for inactivation of PIRS, swine influenza virus, PDB, Seneca virus A, porcine parvovirus, classical swine fever, swine vesicular disease, pseudorabies virus or DhC virus, and African swine fever. You can see we have data for RNA, DNA, envelope, not envelope virus, and in general, when you apply the three different safety steps, you see that we have a total log reduction higher than 10. But to put in perspective, what means reduction of 10 logs? Well, for example, a well-recognized disinfectant, the OIE recognized disinfectant like Bircon, for example, they have a 4 log reduction. This means that they reduce the infectivity by 99.99%. In the case of the manufacturing process of spray dried plasma, the 3 safety steps give you, in the case of African swine fever, 13 log reduction. This means that is 99.999999% effective. This is almost is a very safe ingredient, probably one of the safer ingredients that you can use in the diet for pigs. The European Food Safety Agency, the EFSA, during this year, they have a publication of the risk assessment for feed and ingredients, including blood products for the transmission of African swine fever. They conducted, with an expert group, they conducted a risk analysis about the different feed matrices, about the risk of transmission of African swine fever. In general, the conclusion was that feed and feed ingredients have a very low risk of African swine fever transmission, especially if they are processed. But between all the different ingredients that was analyzed, hydrolyzed protein and blood products ranked the lowest, regarded the lowest risk for African swine fever transmission. And this is because what I mentioned before, the different safety steps involved in the manufacturing process of plasma. And it was the lowest ranked either for large fan or small fans. In summary, about the safety of plasma, as I mentioned, spray dried plasma is collected from healthy animals, inspected and passed feed for slaughter for human consumption. This precludes to collect blood from sick animals and is the first and probably one of the most important safety steps. Blood is collected and processed in a closed system. This means that there is no way of cross-contamination with the environment or with another tissues. The spray drying plants biosecurity ensure that the finished materials is not become contaminated with unprocessed plasma. And in addition, this third-party verification, the University of Minnesota, the EFSA, and others, demonstrate and recognize that multiple hurdles in the production process ensure the inactivation of potential viral contaminants, and conclude that spray dried porcine plasma is a safe ingredient. Then let me introduce you about the use of spray dried plasma as a tool to improve the pig production efficiency. First of all, in APC, we always want to differentiate protein from functional proteins. Proteins, as you know, is a source of amino acid, and all proteins are needed. Well, all proteins provide amino acid and have a nutrition value. But functional proteins like plasma have a bioactivity that is beyond the nutrition value. Okay, if you see the profile of spray dried plasma, you will see that it's very similar to colostrum or the sow milk, and we demonstrate that there is the retain of the biological action that is providing the benefit beyond the nutrition. When you are considering plasma, you need to consider that this is a complex this mixture of different proteins, functional proteins like transferrin, like albumin, like immunoglobulins, enzymes like lysozymes, growth factors, cytokines, bioactive peptides, amino acids, and all of them have an effect on the immune system and the inflammatory response. This is a very schematic way to present what is the benefit of plasma. As I mentioned before, plasma support to have a more efficient immune system response. Basically, what we consider is without plasma, and when there is a challenge conditions, there is activation of the immune system. And the problem is not the activation of the immune system. The problem is the overactivation of the immune system, the overstimulation of the immune system, and inflammation. If the immune system keep overstimulated for a long time, will be inflammation, and then a lot of energy, energy from the diet will be used to support the immune system, and then will be less energy for growth. With plasma, we see that the animal's response, plasma modulate the immune system, the animal responds to the challenge, responds faster, and what is important, come back the activation of the immune system to the normal status as soon as possible, and then avoid the overstimulation of the immune system, avoid inflammation. And because of that, there is from the diet, the energy from the diet, there is less energy to support the immune system and more energy for growth. And basically, this is why we believe the animals fed with plasma grow faster. As you know, the typical use of spray dried plasma is in crib feeding and at weaning. We are recommending 2 weeks after weaning. There are a lot of publications during the last 35 years documenting the benefit of plasma when you put in weaning diets. You see that in average, you increase the average daily gain by 31%, and the animals grow faster because the animals start to eat faster. And you increase the feed intake by 25% and the feed conversion by 4%. What is important at weaning is that the animals keep healthy and start to eat as soon as possible, because then this will help the animals to develop the gastrointestinal tract and have a good start at the very beginning, because it has been demonstrated a good start at weaning is keep and growth over time at finishing time. This is a study that was published recently by the group from New Zealand University. They conducted a meta-analysis review, including 155 publications, and they compare the benefit of feeding plasma on average daily gain and feed intake compared with the control. Obviously, the control was a different kind of proteins, and the inclusion level of plasma was variable between all these publications. But in general, what they observed is that feeding plasma at weaning improved the average daily gain by 43 grams per day during the first 7 days, 30 grams per day in feed intake. During the first 14 days is 27, 28 for average daily gain and feed intake. And most of these studies, they were feeding plasma during the first 2 weeks. But even with that, you can see that the benefit during the nursery period, during the first 40 days, was that feeding plasma improved the average daily gain by 56 grams per day and feed intake by 38 grams per day. This is another study, very interesting study conducted in 2011, was published, and in this study, a group from the United States, what they did is in pigs, they were trying to understand what was the right inclusion level of plasma. They have a group, then a control group without no plasma, a group that was feeding 2.5% of plasma during just the first week after weaning, or a group that was fed 5% plasma during the first 2 weeks after weaning. And as you can see here, the diarrhea score was significantly reduced with when you were feeding 5% plasma for 14 days. 2.5 was not enough. And this reduction in the diarrhea score probably was because there was less problem at intestinal level when they analyzed the activation of the immune system, the inflammation. When they analyzed the pro-inflammatory cytokines like TNF-alpha, they observed that the 5% inclusion level was the right inclusion level to reduce the inflammation, to reduce the activation of the immune system. And when they analyzed the barrier function, exactly the same, they observed an improvement when the inclusion level was 5% during 14 days. Then our recommendations always has been to feed plasma at weaning, minimum 10, 14 days, minimum 4, 5% plasma. There is a lot of studies, a lot of publication, all this has been published that demonstrate that during a disease challenge, spray dried plasma works. Not only works in pigs, we have data in calves, in shrimp, in fish, and in broilers. You see that we have studies that has been conducted with enteric or respiratory challenge, with bacteria challenge, with virus challenge, even with LPS challenge, and basically the results that has been obtained in this study is that plasma improved the fecal score, less diarrhea, improved the average daily gain, improved survival, and the feed efficiency. This is a study that was conducted in Canada, and this was an epidemiological study. Basically, what they did is they analyzed farms that have a lot of problem with PIRS, with circovirus, and with mycoplasma versus farms that have less problem. And they were trying to understand which parameters were involved in the farms that have more problems respect to the farms that have less problem. They analyze the distance between farms, the management, the weaning age. They analyze a lot of different parameters. With all the analysis, they analyzed the odds ratio. Let me explain what means the odds ratio. Odds ratio of 1 means that applying or not applying the specific action have no change in the nursery health or mortality. And then when you have a odds ratio higher than 1, means that applying that action results in a better nursery health and reduce mortality compared with not applying that action, okay? The higher odds ratio you have, the higher chance for observing an improvement in the nursery health and reduce mortality. As you can see here, it's well known that higher weaning weight is benefit the nursery health and reduce mortality. And in this study, the higher weaning weight scored 3.1. But was interesting to see that the highest odds ratio was when was used plasma in the first nursery diet, and the second one was when plasma was used in the nursery in the second nursery diet. This means that in this study, the inclusion of plasma was very well correlated with the benefit in the health status of the farms and improved survival, and was correlated with the farms that have less problem. This is a very recent table that has been published by the Danish Institute just 2 or 3 weeks ago. As you know, spray dried plasma is a very well recognized alternative to antibiotics growth promoter. And here in Europe, next year is mandatory to reduce the zinc oxide level in the feed. Need to be actually with the inclusion level of 3,000 is too high, and then need to be reduced significantly. And this is the recommendation of the Danish Institute for the Danish pig producer. And the recommendation, as you can see here, they are recommending to add plasma 5% inclusion level for pigs that have a weaning weight below 7 kilos. This is again another recognition about the value of spray dried plasma. And then this is the final question about bovine or versus porcine. What is the best? If you know, there are some publications that suggest that porcine plasma is more effective than bovine plasma. There are other publications that just say the contrary of that. And as you can see here in this study, every time that we have been testing side by side the use of bovine plasma versus porcine plasma, we have not been able to see difference between bovine plasma or porcine plasma. The difference is if you put plasma in the diet or not. In this study, we have two different bovine plasma manufacturing lots or two different porcine plasma manufacturing lots. You can see here when we analyze the body weight at day 35, the difference was if plasma was present or not, because there was 750 grams difference in performance. This is a study that was conducted by Iowa State University. It was published 3 years ago. And in this study, they were using bovine plasma, again, just to demonstrate that bovine plasma is as efficient as porcine plasma. In this study, they were working with pigs that was challenged with PDB, and they observed that the pigs that was fed with bovine plasma in the diet, they have a faster clearance of the virus from the feces, much faster than the control. In fact, they finished the study here, and the control still have some virus. And the author explained that maybe was because of bovine plasma in the diet induced an early antibody response to PDB that can explain why there was a faster viral clearance. Well, in summary, this is my last slide. The multiple heartless biosafety steps involved in the manufacturing process of spray dried plasma produce a very safe ingredients for use in pig diets. Spray dried plasma is a functional protein ingredient that can help pigs to overcome stressful events, such as weaning. And bovine plasma basically performs similar than porcine plasma in pig diets. Thank you for your time, and if you have any question, I will be delighted to answer the question. And if you need more information, just contact our technical service team, either in Asia or in Europe.
So let me start a question first to Dr. Sanchez. Dr. Sanchez, there is a question from Thai. I think from Thailand perspective, or maybe from our audience from other countries, seeing it that from the graph that you are showing, seems like Thailand is surrounded by neighboring country that full of ASF. So you love, meaning you know what I am going to ask for. So they want to know, like, what do you think? Is that Thailand free of ASF, or what is your opinion how they can tackle with that?
That is a difficult answer because I don't bring my glass bowl. So
Yes.
I don't know. I usually trust what the authorities of each country said.
Yes.
Normally, this is the way how we have to procedure. And that's the only thing I can answer to that question.
That's very nice already, sir. So it depends on authority declaration. I think every professor will answer the same. So I would like to convey the message again. We really need to trust on what it have happened from our authorities. So the next question, Professor Sanchez. There is question from Vietnam. So this is about the doubt on how your presentation knowing about wild boar. The person, the audience from Vietnam want to know, like, in order to get the number that wild boar is in the high rate and bring risk to the country, how do the presentation has been validated, or the risk validation happen about the wild boar happens in the high rate in Vietnam?
Okay, I'm going to tell you how we do that in Europe. So we evaluated the populations, the total population of the wild boar. So we saw that they increased the population a lot. So this is a factor of risk because it's high populations. So this is one factor. The other factor is that they don't have enemies. I mean, they don't have any biological other animals that can reduce that. So that is the second one. The third is the hunting. Hunting is very limited. So we know that the population is going to keep increasing. The 4 points that we evaluated is what is the presence of this animal in different places, different than their own habitat, with the different habitat. So we found that the wild boar already are not only in the nature, they are also in the agroforestry as well as in the urban. So that means that the risk is really high because they are not only spreading a lot, but also moving in the different scenarios. And so that is the other factors there. Many factors we evaluated to know the risk. Also, the number of outbreak detected in wild boar. So that gives us the information how many of the wild boar are infected. That is another important issue. So at this moment, I can tell you that in the European Union, our biggest problem is the wild boar for sure, for sure. In the other part of East Europe, the problem is biosecurity mainly. And this is important, biosecurity, but because they have also a lot of wild boar. So the combination of high wild boar and low biosecurity is a horrible combination. And if you also include backyard production, that is a cocktail that is horrible. This is the worst cocktail. So that is how we calculated the risk. We have people all the time following everything and making risk analysis all the time, adapting the risk analysis.
It's like the risk analysis happened in Vietnam. OIE also have the team there and evaluate with the cocktail information from backyard, from wild boar, and the situation happened in the region.
This is what I mean. I tell to the guy that made the question, and I thanks to him for the question, that we evaluated many different parameters, including the population, of course, including in which habitat they are already. It's not only in the nature, if they introduce another, the number of break, so they calculate how much animals are infected. This is how we calculated, and we know very well this data for European Union, for Europe in general, very high. Yeah.
Yes. Doctor, the next question would be, you have any recommendation on how to disinfect sewage or the lagoon in the infected farm?
What's that again?
The reservoir for water or even the lagoon?
The water.
Yeah, for wastewater. Yeah. How disinfect that part? Yeah.
We know that African swine fever is very resistant, and we know that can resistant in many different environments. But the important is the concentration, how amount of virus are the dilution of the virus. So we know that the virus is resistant, but we also know that when the dilution is very high, the virus going down. And so that's for sure. And so when you don't have virus enough for infected, is not important. So what I can tell to this gentleman is how we control that situation, how we control water. And so that is a lot of time to explain here. But if they want to send me an email, I will appreciate very much. He sent me an email. I'm going to answer all how we do to control water, because it's complicated. It's not an easy system. Okay.
Yeah.
But in general, he have to be relaxed because it's a big delusion. And the virus is not too much.
Yes.
It's not a problem. Okay?
Even it's resistant, but the composition it is kind of dilute. Okay.
Exactly.
The next question is there is some publication saying that the pig survive after getting the African swine fever. Could you share about that situation? Is that possible that pig has tolerant with the ASF?
We only found the tolerance in Africa with the bush pigs and the facochero. We don't found in domestic tolerance.
All right.
We don't find in domestic
tolerance. No. All right.
We found carriers. We found carriers. That means survivor of the infection. and some of them survivor with no trouble, but most of a couple of 2%, around a 2% or 2.5% of the survivors became carriers. This is what we know. And carriers mean that at any time they can release the virus. Okay?
Yeah.
So to summarize for you, African swine fever not kill 100% of animals, could be survivor animals. These survivor animals usually are clean, but the ones that sometimes keep the virus is around a 2.5% in a chronic infection. So that means that the virus keep in a farm or keep in an area, even that some are survivor, some animals keep the virus. Yeah.
All right. Next question, Professor. Is it possible to repopulate without vaccine?
Of course, we are a clear example of that. Spain, Portugal, soon Sardinia, many countries we finish with ASF and we establish again our system. Brazil was eradicated, even Dominican Republic in the beginning, the infection in the 1978 also was clean, disinfected, and repopulated. Es decir, the possibility to finish with the virus, if you have a good program for clean disinfection and a control to be sure that you clean and disinfected areas or countries, is very interesting. How we know that? We do on the farms. We have a very good system for clean disinfection and later made sentinel animal to be sure that are clean. Or also the sponge that I told you. The other point that have to be is if no animal infected around the areas that has been not ASF. So for that time we do serology to be sure that everything is clean around. So of course, after an outbreak of ASF, you can be starting again. The important is to do good, because most people try to do very fast, and that's not good. When you go fast, you leave some virus there. So you have to do a good program, and many countries recover of ASF and working again, for sure. Yes.
I think, Professor, in ASEAN like Vietnam and Philippines, if the farm got ASF, to reopen the farm again, it's now very difficult. And government already put a clause in action, like you need to do this biosecurity, things like that. So it's really see the improvement in terms of biosecurity in the ASEAN country. Yeah.
I can also tell you how we do that.
Please.
I mean, the system is safe when you. The important is to know exactly how to clean, how to disinfect it, and be sure that the farm is clean and disinfected. And the best way is to have sentinel animals. So you keep little piglets moving freedom around the farm for several days, for a few weeks, and later you testing all these little fellows all the time to be sure that there's no virus or not antibody. Also, you can do these sponge studies. Once that you don't find any residue of virus, you can be sure. And so how we repopulated is to include a very small part of the repopulation, 5 or 10%. We repopulated with that. If again we checking the animals before the full repopulations, we check several times. And once that is doing everything all right, we start again. Normally is a time is 45 days, between 45 days to 55 days, the total testing. But of course can we do that? Sure. Okay. Other thing is that they can be reinfected. That is another possibility. I mean, you can start again and be reinfected if the country is infected. But you can clean the area and start it for sure. This is, we did in countries, we did in farms, and we did everywhere. The problem that I observed in some places of Asia is that they want to repopulate very quickly. I mean, they clean very quickly, they don't make sentinel, they don't make tests enough, and they put animal again, so they're reinfected. But this is a time to do that. It's because they are not doing properly the control.
Yeah. So I would ask Dr. Javier to add on this, because Dr. Javier might spend a lot of time in the farm as well. How you see the improved situation that when the farm has ASF and how you see that the farmers can do better. What is the application or implementation should be on?
Well, basically, I fully agree with Professor Sánchez-Vizcaíno. I think that the speed in moving the farm to repopulate, if you go too fast, is a real issue, because, as he mentioned, you need to put the sentinel. Otherwise, it's not sure that this virus is very resistant, especially if there is organic material. Then you need to make sure that you clean everything, you have all the biosecurity measure in place, all the strategic plans in place, not go too fast repopulating, make sure that you take the time and do correctly with a strategic plan and all the biosecurity controls in place.
I even can address more. If you remember last time we discussed with other professors, also they mentioned about the sourcing of the quality ingredients or quality crop inside. That should be happen as well. How you see APC playing the role to help the industry in terms of improving the situation, reduce ASF, or
we have conducted we are working very close with the CRESA. The CRESA is the research center for emerging disease here in Spain, in Catalonia, and they are the emerging disease reference lab for OIE. Obviously, we are interested in the African swine fever. We conducted several studies with them. And what we know is that plasma, because plasma is able to modulate the immune system, can be a good tool it's not to avoid, because plasma will not avoid infection at all. But plasma can mitigate the negative effect of the African swine fever. We are now involved in a study. They're working with a European pharmaceutical company, and they are developing a vaccine for African swine fever. We are working with them just to know if plasma can make the vaccine more efficient. The initial results, but very preliminary results, to be honest, and has not been published, suggest that plasma can help on that. And what we know is plasma modulate the immune system, then maybe can play a role in the case of the vaccines. But plasma will not avoid the animals to be sick, because it's not antibiotics. Not
so
will not avoid that.
The APC, the way you work, not only offer the solution, but you're also working with different university, working Dr. Sanchez in developing what is sustained in the production by approaching nutrition and do up-to-date situation was variant of the ASF. I was like want to have one personal question that I would ask. Like here we hear about Delta Plus for COVID. ASF is in the similar way. They turn the variant all the time? Or?
I think that the COVID virus is very different than the African swine fever, for sure.
Yeah.
But for example, interesting that we are working together with the hospital here in Barcelona, Hospital del Mar. We are doing a trial with the patients that are infected by COVID. Not the ones that are in the intensive care. Obviously, it's just the ones that are in a previous status or are less with less problem of COVID. And basically, what we know is plasma modulate the immune system, as I mentioned before, reduce inflammation. We know that plasma also reduce inflammation at the lung level. We have been doing a lot of trials demonstrating that. And in this specific study, that again we don't have data yet because it's ongoing.
Going on, yeah.
The idea is that if plasma reduce the overstimulation, reduce the inflammation at the lung level, this may help the patients that have not a severe COVID situation. It's not for the severe COVID situation.
Yes,
But
yeah.
again, this is a study that we are conducting
Yes,
with in a hospital here in Spain, and it's not finished. Then we don't know if this helped
Yeah.
or not.
Yeah. All right.
We'll
So
see.
the question will come back to Professor Sanchez. Professor, this is kind of on your opinion, the high level on the idea. Professor mentioned education of farmers and veterinarians as a way to reduce and stop African swine fever virus spreading globally. Seems that some country authorities have not done much. Not reporting outbreaks, giving no compensation to the farmers. So how to be more effective on that level? Just seeking the opinion of you.
We have to convince the people that don't believe it in the education and the training and the compensation. I can give it information enough to any country or any administrations that would like to know the advantage to have education on the farmer, education at the veterinarian, and compensation. We did that in many places, and I can promise you that when we influence in that 3 points, the situation is much better. Sometimes I found countries that don't have money enough to pay compensations. In that case, what we did was as insurance in the private producers make an insurance, and they protected themselves thanks to this insurance to protect themselves. And they working beautiful. I has been working in countries that do that, and that really is running well because they prefer to pay a little more money and have an insurance than nothing and have one infected guy that is going to spread the virus around. And the other points in relations with the education of farmer veterinarian, I think it's a very important thing because most people don't know the mechanism of transmission of ASF. For example, I'm going to give you a very stupid example. You are a farmer and you are a worker in a farm and you are in home and you are in an infected country, but you know that you have to be carefully, but not enough with your sandwiches because you are going to eat in the farm. You take the food to eat in the farm, in a place of the farm, you're going to have your lunch. And you take these salamis or these kind of things, and you don't realize that could be infected. Many people don't think that's something that they are eating. How can be infected if I eat? So this lack of information about ASF is one of the biggest problems that we have for so much transmissions. I told you the biggest transmission is through the food. It's absolutely like that. And the people don't realize.
Salami is stay for months, right?
Salami, you can have the virus. Virus like salami.
Yeah. So Professor, now connect to like bringing food in the farm might cause like importing things like they did without knowing the effect. So right now the question is kind of if the farmers using the vaccine, which is illegal, the illegal attenuate vaccine, what you foresee if that happen? What will be the really effect happen?
Well, I can give an example of China. That is an example that even the Chinese already declare, and that is very good because they make the publications and they aware that this is happened. So they are doing the lexion genes vaccine and they reduce the mortality, but they don't finish totally with the infection. And so that is what they describe it in the paper that I mentioned to you. So from the legal point of view, in some countries, it will be impossible to do that. Absolutely impossible because will be declared as illegal. In other countries, they said, well, if I don't have a product in the pharmacy or in the drugstore that solving my problem, I can do myself something, like because I have to do like auto vaccine. So vaccine that is That's sometimes, and some countries, they do that. I don't have a vaccine for that, but I can do auto vaccine. And this is already permitted in bacterial, even in some viruses, but not in diseases like ASF. But in other countries could be not illegal. So the tendency because the people need some solutions. And if you don't have a commercial vaccine and you see your animal die very quickly, and you lose money because you don't have compensation, this is having the people too much stress. We have to help him, and it's better to help him from the administration that let the animal, let the person to find a solution, a bypass solutions that normally is bad for everyone.
Yeah, so ASF solution must be the nationwide, which is from government, every sector all together.
Yeah, I think in this type of things, we have to work together.
Yes,
administration is important. It's very important because a country is very important. It's not only your farm, it's the picture of your country outside. And you have to know that your products are safe to go out. You have to be less restriction for your tourists, less restriction for your people. One country infected in diseases like ASF is creating a lot of trouble to the country, not only to the farmer, to the country as well. So in these particular diseases, we have to work in together, and we have to help in each other very much.
Yeah, absolutely.
Doctor, the next question would be, this is an implementation at farm level. If my farm has ASF positive, can you suggest a way that I should destroy all the pigs, or how should I separate and destroy? No condition whether get compensated or not, Professor. So
yes,
that is
I understand the question. I understand the question. ASF is not an explosive disease. It's not an explosive disease. When they enter in one farm, normally enter in low doses. Enter in low doses. For example, going back to the salami, the rest of the salami of the worker that I mentioned to you, if they leave something, it's going to be eaten by 1 pig or 2 pigs, not by 10 or 20. So even in the case that you have an early detection, and early detection means that you will be the sick animal and you sacrifice, the virus is already there. The virus is already there. And probably you try to move this animal out or try to evaluate it and study this animal, you are going to be the one that are going to contaminate the whole farm. The farm, your farm, and the farm or your friends. So it's a very, very dangerous disease. So it's much better to finish with everything and clean everything, disinfect it well, put the sentinel, be sure that there's no virus, and start again. What happened that most people try to do faster, and that's why they lose time. But you know what happened? In some places, I asked it, but you don't know this is going to happen, an infection again. He said, yes, I know, I have several, but I still sell my product, and I lose less time selling even a few animals and not the total animal that have this empathy for 45 days because they don't have compensation. So this is how you have to put in the mentality of the people. If you don't pay, you pay later more. If you don't want to pay to the cheap, it's always expensive. And this is something that many administrations don't understand. They don't want to pay the farmer, and they don't want that the farmer reinfected. It's impossible. He is going to survive. So you have to be generous, and you have to think in that it's better to pay once that stay paid the whole life.
Yes.
With the virus all over. And this is very, our knowledge of the disease is too clear that we can prepare a program that is going to work. But we need to clean, disinfect it, and wait the time enough to be that the virus is not in the farm. And that is 45 days. What happened with the people? 45 days empathy with no money for compensation is bad for them. So what they do? I start again. And if I start again with the disease, I sell very quickly all the other that are still walk. Because if they walk, they're going to buy it, And the walk can have the virus already. And this virus go to the meat and to the salami and coming back.
So that there was a follow-up question from what I just asked you now. Also, like, Oh, only the choice is only to depopulate. So you are addressing here. Even you are going to depopulate, you have to have the resting time, withdrawal time long enough, minimum 45 days. That's what you mean, right?
Yes.
Okay.
This is what we do. Yes.
Yes. Doctor, the next question is from our Philippines audience asking that they know that government has some of the training, regulated training to stakeholders for farm, vet, transport should be given country at higher risk of infection. Do you think that approach by government provide a regulated training only will help, or you mentioned about the compensation as well? That's part. Anything else you think it would help the farmers to survive? Because I think Philippines by this year from 2019 already 3 years on ASF. Yeah.
No, I think that everything is helping very much. And it's very important to know that the farmers are protected. The people need to know that they are protected in this fight against the disease, that they are not a single guy, that there is a country there. And the country have to take care as a country, not as individual people, because this is a disease that not affected only individual farmer or individual people. They affected the whole country. And this is terribly important. And I really recommended to the administrations to really make a good contingency program for ASF and be generous in this ASF program, because it's important that the farmer really receive something when they are suffering, because they cannot be with no salary and they cannot see all these pigs that they still walk, that somebody come in and kill her. They're going to walk with the pig out, but this pig is going to be infected.
Yes.
Almost very highly infection. So that's the problem. That's the problem in most of these places, that they are going to keep the virus and the disease for long period of time. And this is not only a problem for that country, it's already a problem for a world, because that means that many products from this country could be infected. And these products are going to leave the country and go to other places. And in these other places, somebody is going to give it to the pig by swill feeding, and they're going to start again. So it's a big world problem. It's a world problem.
Professor, now come to the very last piece of this information, because we got about 20 over question. So come to this point, is it the partial depopulation, or it's called tooth extraction? So calling only those who get ASF in the farm. It is effective way. I learned from you it's not the right way. So
no, it's not the right. It's not because they only going to see a little group infected, but the virus is working, and the virus starts
already walk in. Yeah,
it's working. They working, and they know very much how to walk, how to be in a height, waiting for a probability, and the virus start. It's the same people that do depopulation, and repopulation. They depopulated partially, not totally. And they thinking are safe. No, because the virus is in the farm. Somebody has been moved with the boot to one place or another. So the virus, when it's infected, is very resistant. And they're going to be some little coins. So what I recommended, honestly, is to finish with the area. Not with the whole farm if you don't want, but at least with the area with people, all the area that is in common people. If several people are moving in the area is all where the people are moving, not only one place where the disease starts. Everywhere where people has been moving, everything that are connected have to be cooling, have to be clean, have to be disinfected, and have to be biologically tested with Sentinel, with a sponge first, later with Sentinel, and finally with a 10% of the production. Only 10%, not the 100 again full, because it's more money to lose. What happened is, as I mentioned to you, they don't lose so much the money because it's no compensation, so they try to sell as much as they can. And some of these sales that they do have the virus. Probably not all, but a few for sure are going to have the virus. So it's going to be a meat, or it's going to be to another farm, or a truck is going to be infected, secondary outbreak. That's it. Is the history. That's the
So
history.
don't avoid to do things, and at the end up you pay more to do inevitable things. That's what we are going to end up like that. So right now, come to the end of the session, Professor. Thank you very much, and I would like to invite Mr. Ramesh to give like a word of thanks to the speaker here.
Okay.
Sure,
Thank
Ms.
you
Rose.
very much.
Yeah, thank you, Professor Sanchez, for your very enlightening speech. I think the industry will be highly benefited by the knowledge sharing. That's what we expected from this exercise. So we would keep in touch. There are a lot of questions that has come. We usually prepare a newsletter, a kind of article after the webinar, so that some people who have not attended and who wants a follow-up notes can have it. So we will prepare a draft and send it back to the speakers for their verification, and then we would recirculate it among the audience and the industry at large. And also, as Professor Sanchez said, if anybody has any specific questions, if you could send it to us, to Tapani, and she will compile it and send it to Dr. Sanchez as in one go, so that you can answer them when you have time. So we appreciate your time, Dr. Javier, also for your time. And we look forward to more interactive sessions, webinars, and topics in the future. Thank you very much.
Thank you very much, Mr. Ramesh. And ladies and gentlemen, to our audience, I would like to thank you for staying with us, and please stay tuned with the APC coming webinar, which bringing the expert on behalf of the organizer. If any extended time, I apologize for that. It's really practical information and is useful information brought in by APC. Thank you very much, Dr. Javier, Dr. Jose, and Mr. Ramesh and team.
Thank you.
Thank